Hi guys, here we have a lesson on solubility table. So to start off with, let's look at the word solubility and talk about what that means. Solubility is a fancy science way of saying how dissolvable is a substance. If a substance dissolves really easily in water, we would say that it's very highly soluble. And aqueous is the subscript that we would use after the chemical formula. So if something dissolves in water and it becomes a solution, then we would call that aqueous. So if I went to my kitchen right now and I took salt and water and I dissolved some salt, just plain table salt in water, I would get a solution of sodium chloride, NaCl, or table salt. That would be NaCl with aqueous written behind it, not solid like we originally have with solid table salt. So on page 10 of your data booklet, you have what we call the solubility table. This table shows us for ionic compounds which compounds will be aqueous solutions, or which compounds are likely to dissolve really easily in water. So over here on the side, you can see if something is very soluble or aqueous. This is something that would dissolve easily in water, like sodium chloride. If you have something that doesn't like to dissolve, like candle wax, if I put that in water and stir, it just won't dissolve. That's going to be slightly soluble, and we would put a solid behind that chemical formula. Now, this doesn't mean that wax would never dissolve in water. For most compounds, if you heat the temperature up and agitate it enough, things will eventually dissolve in water. But for us, we're looking at room temperature, standard conditions. Would that thing, if I went into the chem lab right now and put sodium chloride in water, could I get it to dissolve? Yes. If I put wax in water, I couldn't. So that's what this chart is trying to tell us. At the top, this is where you're going to start, and you're going to find your ion that you're working with in your chemical formula. So for our first example, sodium chloride, table salt, here's the chloride ion, okay? Now, you can see most of these are the negative charges, so most of these are going to be your non-metals that you're looking at first, or your polyatomic ions. There is one positive charge, and there is a part that says group 1 ions. So sometimes it takes a little bit of looking to see where your ion might fall, but for us, here's chloride, the chloride ion. And now I'm mixing it with sodium, so Na. So if I look down, straight down, I want to find sodium in this list, and I can't find it in any of the listed ions here. So that means it falls into this category, most. If we go back to the notes, it tells you that most means most compounds containing the chloride ion will be, in our case, very soluble. So see how most lined up with this row here of aqueous? That's what it's saying, is that chloride ions with most other ions will be very soluble or make an aqueous solution when dissolved in water. If I think about these exceptions, these ones like copper 1, if I combine that with the chloride ion, that's not going to give me an aqueous solution. It doesn't dissolve easily in water, so it will give me a solid. Let's try a few examples. NaCl is the example we just did. We discovered that it's very soluble, so we would write aqueous behind NaCl. The next one here, we've got chloride again, which we know is a charge of -1, and we're seeing 2 ions. So 2 -1 charges would make -2. The reason why I'm doing this is because I need to figure out what lead this is. Is it lead 2 or lead 4? So that I have 2 chloride ions that make -2 would mean this one lead is +2. So let's go see if lead 2 is in that list under the chloride ion. So here's the chloride ion again. Is lead 2? Yes, it is right there. So lead 2, when combined with the chloride ion, falls under this category on the side. It's slightly soluble, so we would write a solid behind that compound. So when I write this compound out, I'm going to have to include this solid in brackets after the compound. Try the next one. Same idea, but this one now has 4 chloride ions, making a -4 charge, which means this one lead ion needs to be +4. So this is now lead 4. If I look at the list again, I've got copper, silver, lead 2. I don't have lead 4. So that means that lead 4 is up here in most ions. If you don't find it in the exceptions, it lives up here. So lead 4 is in here, meaning it makes an aqueous solution. Lead 4 chloride would have aqueous behind it. Now that you've practiced polyatomic ions, you might be recognizing them a little bit easier. SO4 is something that I recognize from the polyatomic ions. Here's SO4 at the top. If you don't know your polyatomic ions, you might be looking for O4, which you would never be able to find. So you need to memorize your polyatomic ions. SO4 is here. It's going to make an aqueous solution with most other ions, except for this list, which would stay solid. So what we're mixing with SO4, is it any of these? We're mixing it with barium. There I see it, right there. So this is going to have solid behind it. Next one. We have sulfur here and chromium. So if I look at the top, I'm looking for sulfur and chromium. I can't find either one of those on this solubility table. So when you see that none of your ions are listed, that means that you're going to default to what we've been doing all along. We know that most things are solid at room temperature when we're making ionic compounds. So what I'm going to do with this one is I'm just going to call it solid as a default. Okay. Next one. CH3COO is something that I recognize from my polyatomic ion chart. Here it is. Now, do we have any of these mixing with our CH3COO? No, we have cesium. So that's going to fall under this category. None of these are cesium and CH3COO, so we're going to write aqueous behind that one. Last one, CO3 is right here on the solubility table. So unless it's a group 1 ion or NH4, it's going to be solid. Now, I have to decide, I know it's not NH4, but I have to decide if this potassium is a group 1 ion. How am I going to decide that? Well, I need to know what a group is on the periodic table. Your groups are these numbers along the top. They're the columns. So if potassium falls in column 1, then I would write aqueous. If it doesn't, I'm going to write solid. So I look down column 1 and I do find potassium. Potassium is a group 1 ion, and our solubility table here is telling us that with CO3, a group 1 ion would form an aqueous solution. So I would write aqueous behind that. Now there is a worksheet that goes along with this section, but I'd also like you to go back and practice, because every single ionic compound we've done, you can now use this method to determine if it should have been solid or aqueous. So there's lots of questions that you can practice with. This is a very important skill to know. So please let me know if you have any questions at all. Don't hesitate to ask.